Hello, Grayton. Good day, Grayton. So, in this video, we are going to discuss a topic from a connect section. But before that, let us have our short opening prayer as usual. Let us have the presence of the Lord. Let us bow our head. In the name of the Father, the Son, and the Holy Spirit. Amen. Lord, we offer you everything we do today, all our works, our joys, and our sorrows. Everything will be an act of love for you. Holy Mary, Saint Joseph, Saint Joachim, and Saint Anne, and Guardian Angel, intercede for me so that I may be deserved to be helped and saved today and always. Virgen del Pilar, pray for us. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, so as I mentioned a while ago, we are going to discuss a new discussion in context section, and that would be hyperbola. All right. So, last discussion, no, in our last video, we discussed a part or one of the kind of conic section, isn't it? And that would be our ellipse, correct? So let's have a recall for the ellipse, which uh yes, ellipse and parabola, correct? So let us have a recall for ellipse and parabola, no? Before we proceed to hyperbola, right? So in ellipse, we discussed an equation, no? The standard equation of your ellipse would be x squared minus a squared minus y squared all over b squared. Okay, so this is a standard form, it's equal to 1. This is a standard equation, no? Or a standard form for the ellipse when the center of an ellipse is at the center. Okay, so while in parabola, we discussed that it has standard form as well. When we could see that the axis of symmetry is at x, let's have it on x first, not all of it. So we have y squared is equal to 4c x. So there are two things in parabola when the parabola is facing positive, no, or at the right side. So this is your standard form. And when your parabola is facing at the left side, and it would be y squared is equal to negative 4c x, correct? So this is where the axis of symmetry for your parabola is at x-intercept. While in your ellipse, this is the standard form when the center is at the origin and your principal axis is at x-axis. Okay, so how about for y? So for y, we discussed that um, the standard form for the ellipse when the principal axis is at y-axis and the center of your ellipse is at the origin, it would be x squared all over b squared minus y squared all over a squared is equal to 1. Correct? So this is the standard form when the center of your ellipse is at the origin and the principal axis is at your y-axis po. Okay? And for your parabola, uh, the standard form for your parabola when the axis of symmetry is at y-axis is that there are two things, isn't it? So we discussed that there it is x squared is equal to positive 4cy when the parabola is facing upward, correct? And when your parabola is facing downward, it would be x squared is equal to negative 4cy. Alright, so there are two things in parabola. Okay, and there are two things as well in ellipse, which is based on the principal axis, correct? Alright, so two different things and two similarities and differences of these two conic sections for our new topic is that for your ellipse, this is your ellipse, okay, okay, and this would be for your parabola, okay. All right, so with these two, there are similarities and differences for your hyperbola, okay. All right, so for similarities, let's look at with the similarities first. For the similarities in ellipse, the similarities that we could see is the equation, okay, equation. And for parabola, the similarity for parabola is that the visual representation. So let's talk about with the parabola. So in parabola, parabola forms a U shape, no? U-shape form where it is consists of points, no? From our fixed point and fixed line, which is the directrix and the focus, no? So how did we say so that it is similar for our hyperbola, no? So we say so that it is similar for our hyperbola. It's just because, no, in hyperbola we visualize, no, and we can see in visual representation that there are two parabola in our graph, okay. So the similarity on this parabola and hyperbola is that in hyperbola you could see two parabola, no, instead of one, okay. And for ellipse, the similarity that you could see for ellipse for your hyperbola is the equation. Why did we say so that it is for the equation? So for the equation, as you noticed, for the equation of the ellipse is starting with x squared over a squared, correct? So this is the, I'll be highlighting, huh? So for your uh, this one, for your ellipse, you start with x squared, ends with y squared, correct? And it also starts with a squared, then ends with b squared. But these variables in your denominator changes, correct? It changes depending on what principal axis do you have, correct? So when the principal axis is at x-axis, your a squared is interconnected, or it's with your x squared, correct? So when your principal axis is at y-axis, the two variables in your denominator changes places or switch places, no. And as you will see, a squared is located at your y squared, so this indicates that your principal axis is your y-axis po. Okay, so what is the similarity from the equation of ellipse into your hyperbola? Okay, so the similarity is that it has two fractional bars, correct? So it has x squared, y squared is equal to 1, and as well as the variables. Okay, so these are the similarities, but what are the differences between them? Differences is that starting with the operation, because the operation that we have for ellipse is that we have, I'm sorry, please wait, I'll just correct this one. Okay, so the operation that we have for ellipse is that we have positive. Okay, we have positive. Instead, for hyperbola, we do have negative. Okay, so that is the big thing that you could notice if you are given an equation, and you will notice that if the operation between the x variable and y variable is subtraction, so therefore it is a hyperbola. Okay, so that is the first thing. So what else, Sir Jai? What is the second differences that you could see for the equation of your hyperbola? So the second differences that you will notice is that when in ellipse, we could identify what is the principal axis depending the placement of your A's and B's, correct? So when your A is located at the x-axis or x squared, so the principal axis is at x-axis, correct? So in hyperbola, the difference between them is that when you have the variables below or in denominator, in ellipse it change or it switch places, correct? So in hyperbola, the only thing that changes places or switch places is that your numerator. So your denominator will be fixed at that placement, while your numerator will be switched depending on what is your axis. Or later on, we are going to talk about what is that kind of axis, the transverse conjugate. Okay, so at that moment, if we say so we switch places the numerator, we could have y squared over a squared minus x squared over b squared is equal to 1. So this is how we could see for the equation. But Sir Jay, what is the similarity for the parabola? Once again, you mentioned, Sir Jai, that it forms two parabola or parabolic structure in the graph, correct? So let's have this equation as we show the graph, no? So when we have this kind of equation, this is the equation that we use when the center of your hyperbola is at zeros, correct? So we tackled about when the centers vertices is at or the origin, when we cannot see any values of h and k, and that is the quickest way in order for us to know and to identify whether the values of our centers and vertices have h and k. So if you're going to graph this one, if this is your coordinates x and y axis, your parabola is facing horizontally. So as you will notice, no, you still have this a squared in this part. So I will be giving you a big tip in order for you to know whether what is the placement or how is your graph being drawn if you have this kind of equation when the x is at the first place or at this moment. If you will see, x is the first term that you could see, rather y squared, and when the time is your y squared is the first term, then your x squared is the second term. How can we identify it fast whether your graph is facing both left and right, no, it is in horizontal manner, or it would be faced upside down or a vertical manner. Now, so once again, coming from our a squared, because that is our key point in all the connect section, correct? So once we have the a squared, we could identify already if your graph is facing either left or right, or from the horizontal or vertical. So if you see that your a squared is at the value of x, so therefore your axis of symmetry is at x-axis. Correct? Correct po. Sige. So, how about for the second equation? So we do have a squared along with the y squared. So therefore, we could say that the axis of symmetry, this is for x, the axis of symmetry is at y axis, correct? So it is facing upwards and downwards. Okay. All right. So let's talk about with the variables that we have. So if you will remember that in in parabola, we were able to find, no, we were able to find, I'm sorry, in ellipse, we were able to find the value of c. Okay, we were able to find the value of c by using what? What is the formula? The formula was coming from the Pythagorean theorem, no? But the difference between Pythagorean theorem and the formula for the ellipse in getting the c is that it is being subtracted by b squared. Now the a squared is being subtracted by b squared. So therefore, the operation between a's and b's are is uh, subtraction pa. Okay? While this is for ellipse, correct? While when we have hyperbola, in order for us to get the values of c, is that we have the formula c squared is equal to a squared plus b squared, and that is the formula for hyperbola in getting the c. Okay, so if you will notice, this is just the formula of the Pythagorean theorem, but there is a twist. We were able to get the vertices, no, and co-vertices every time and then, correct, every time and then when uh when we see the values of a's and b's, no, are larger or smaller, correct? So we are basing on the vertex. If we saw that the number in our denominator is larger, then we could tell that that larger number is our vertex, no, and that would be our principal axis, correct? But in this case, as we recall what I've mentioned a while ago, our denominator will not move and they will be fixed. So therefore, always our left side will be always our a squared. So whatever, even though a squared is lesser or it has the least value compared to our b squared, it will be always our a squared. Okay? Alright, so that is the twist. Now, and in hyperbola, there is what we called asymptotes. Okay? Okay, we have asymptotes. So what are the asymptotes? Later on, we are going to discuss that one. But to give you a tip, no, these are the lines that is being created in our graph of our hyperbola. Okay, these are the lines that is being created, vertical lines rather, that are being created, which leads our graph, no, towards to our asymptotes. But no, they will meet, but they will never touch. Okay, the graph and the asymptotes will meet, but they will never touch. Okay, so that is what asymptotes are, no, so the level or the boundaries that we have for our graphs po. Okay, so of course we also as we mentioned a while ago, we also have the center, the vertices, and we also have foci, huh? Why did we say so foci? Because we have two parabolic figure, correct? So therefore, there are two focuses. There are two focus. So therefore, we have foci, and we also have this co-vertices. Okay, co-vertices. Let's type it as co-vertices. All right. So we're going to find these things later on. Okay. So uh, to make it straight, let's go now already with our objective. So what is our objectives? Our objective is to write the standard equation of a hyperbola. Okay, so I did teach you already. I taught you already with regards to converting standard equation to general equation to standard equation. Now, and we are going to graph a hyperbola and identify its center, vertices, co-vertices, foci, and asymptotes. Okay, so these are the things that we need in order for us to graph the hyperbola. Alright, so with regards to this standard equation, let's have this example so that you will be refreshed. Okay, alright, so we do have here for number 1, x squared over 9 minus y squared over 4 is equal to 1. If you will notice, this is written in standard form already, correct? And this is an equation of an hyperbola, correct? As well as this second equation. This is an equation of a hyperbola, correct? All right. So our goal here is that we are going to convert the standard form. Let's write it down as SF. Alright, so this is our standard form, and we are going to get the general form. Okay, alright, so first things first, how are we going to convert this first equation to general form? Alright, so if we are going to state what is general form, that is the 1 horizontal equation, isn't it, that doesn't contain any fraction or whatever, correct? So in an equation that composes of squares, alright, so once again it will form as the normal equation that you could see on your given. So therefore we are going to disseminate this this denominator by how are we going to uh, diminish this denominators? How are we going to remove that one? Because as we said that in general equation, okay, or general form, we cannot have any denominators below. So how are we going to convert that one? So first things first, if you will see, there are two fractions, correct? So in your two fractions, what are we going to do in order for us to get only one denominator? We are going to get the LCD. So how are we going to get the LCD? So in order for us to get the LCD, we're going to get the LCM of the two denominators, correct? So what are the least common multiples of 4 and 9? What do you think? So we have 4, 8, 16. We have 4, 8, 16. 12, 16. We have 4, 8, 12, 16, 20, 24, 28, 32, okay, and 36, 40. How about for 9? We do have 9, 18, 27, 36, 45. So with this, what is the common multiple that you could see among them? So the common multiple is 36, correct? So our less common denominator now is 36. Now, and if you will notice, that will be the denominator for both fraction, because if we got 36 already, let us copy the operation that they have. Alright, so in this case we could have the least common denominator, we have the 36, and how are we going to get the numerators for both sides? Because yes, we have the operation which is subtraction. How are we going to get the numerators for both sides? So in order for us to get the numerators, we are going to divide 36 by 9. So 36 divided by 9, that is 4, correct? And 4 multiplied by x is 4x squared, correct? So how about for the other side? So you have 36 divided by 4, the answer is 9, correct? So 9 multiplied by y, the answer is correct. So it is 9y squared. Alright? So how about this one, Sir Jai? Because we still have 1. So it turns out that it will be just like this. Huh? Alright. So are you telling that, Sir Jai, that that would be the final answer? So our final answer would be like this. We're going to diminish this 36 because this is the only thing that we want to remove in our equation, correct? So if we have 4x squared minus 9y squared over 36 is equal to 1, in order for us to remove any number in your in your denominator, we are going to multiply both sides by 36. So this is for 36. So 1 multiplied by 36, it would be 36. So 36 divided by 36 is 1. So therefore, in this case, we could have the denominator of 1. And we could get the final answer, which is 4x squared minus 9y squared is equal to 36. Alright, so that is our uh, general form. Okay, so how about for the second one? So let's try po. Same process. We're going to get the LCD first. So the LCD is that we're going to multiply them first. So we're going to multiply 16 by 100. Oh, let's try first by 100, because if you will see 100, the half of 100, if you're going to divide that by 2, the answer is 50, correct? So once you are going to divide it by 2, once again, it will be 25, correct? So in this case, let's try to multiply 16 by 100. So 16 multiplied by 100, obviously, you're going just to add 2 zeros at the end of your 16. So you will have 1,600, correct? So what you did in here, in order for you to get 25, is you divide the numbers twice. So you divide numbers twice by 2. So 16 divided by 2, the answer is 800. Correct? So once again, you divide 2 by 50, coming from your 50, so you have 25. So 800 divided by 2, the answer is 400. Correct? So same goes by, if you're going to multiply 25 by 16, it is just the same. Okay? So 5 times 6, it is 30. 6 times 2, the answer is 12, plus 3, it is 15, correct? Alright, so because this is 1, you just copy all the numbers that you have, it is 25. So in this case, you're going to add both. You have 0, 5 plus 5, the answer is 0, 10, carry 1. So you have 1 plus 2, the answer is 3, and carry 1. Just add that 1, and you will be having 4. So same goes by, no? So you could have 4, and that is your LCD. Okay, once you multiply, because you will see that the multiples of 16 is up until 400, could be, right? Or you just add that one, or you just find the multiples if you have time to get the multiples. But in the quickest and possible way, no, in order for you to find the LCD is to get the LCD by multiplying both denominators. Alright, so we were able to get the denominator, which is 400. And with that, let's copy the operation, which is negative. And we are going to get the left numerator and the right numerator. Alright? So your left numerator is, we're going to divide 400 to your 25, and that would be, what's the answer? It will be 200 or 100? It will be, really? It will be 16. Okay, 16. Alright, and with that said, are we going to have 16 as your numerator? Not, because once you divide, you're going to get the product of 16 and y squared. Alright, so with that said, we have 16 y squared, correct? Alright, so with that said, we have 16 y squared. Alright, next in line, we have 400 divided by 16. What is the answer? It is 25. 25 multiplied by x squared. The answer is 25x squared. Alright, so don't forget you have still the equal sign for your 1. Alright? Sige po. So with that said, are we done already? No, because we still have the denominator. So in order for us to diminish that 400, we're going to multiply both sides by 400. So in that case, 400 multiplied by 1, the answer is 400. And 400 multiplied with this 16y squared minus 25x squared all over 400 is that we are going to diminish and cancel this 400 already, and you will be having 16y squared minus 25x squared. Alright, so you have that one. Alright, so multiplying both sides of each equation by the least common multiple eliminates the fraction. So that is how, like what I said, find the least common denominator by finding the least common multiple. Alright, and with that, you could have at least the general form instead. Okay? Alright, so next and next. So let's have this thing. Alright, so the question that we have is that a while ago you said, Sir Jai, that it is somewhat somewhat an ellipse, correct? And it is somewhat a parabola. So let's go first in ellipse. So if you have an ellipse, okay, and this is your, I'm sorry, so this is your graph, alright, or your Cartesian plane, okay. So you have your vertices, correct? Correct. And you have your focus. So let's have your focus. So your focuses, as you will remember, mentioned that you were able to get the ellipse when you have this kind of formation. Let's just say this left hand and right hand forms an ellipse. Okay, so without your left hand, you can't have any ellipse. Correct? So in this two left hand, with this right two hands, I have focus. Alright, so let's just say these are my focus. Alright, so as you will notice, if I will be removing my one of the hands that I am showing to you, is that we will be having a parabola, correct? And as you will notice, the curve of the parabola with your focus, the parabola is opening towards your focus, correct? And it's basing on the focus as well, correct? Same goes by at the other side. So this is the question, no? This is the question. What would happen if we are going to pull, no, the two focus, okay, of an ellipse apart from their ellipse or from their figure outside of them, okay? So in this manner, for example, this is your ellipse and this is your focus. What if your ellipse what if your focus will be moved outside of the ellipse? So what happens is that the U shape of your graph will be turning outwards. Okay, turning outwards. If this is your ellipse, no, it will be turning outwards. All right. So that is how. That's why you have hyperbola. Okay. All right. Why did we say so? Because the focuses, if this is the focus, it will turn out in this position. So your parabola will be focusing at that side. Same goes by at the other side. Alright? So that is the visual representation for the hyperbola. Okay? And that is what I am saying. That is the result of a hyperbola. Or another conic section po. Alright? Okay. So what is a hyperbola? Right? So a hyperbola is a set of points wherein your point is composed of the x coordinate and y coordinates in a plane such that difference of the distances from the point to the fixed point, which is your focus 1 and focus 2, which are the foci, is constant for a hyperbola. So same goes by from the ellipse. So if they are a fixed point, therefore it is a fixed point as well. Okay. Okay. So we do have d. Okay. D is equal to the magnitude of the point multiplied the focus 1 minus the point times focus 2. Alright, so wherein d is the constant difference that you can use the distance formula to find this equation of the hyperbola. So I will be showing you these two forms of hyperbola, which is the horizontal and the vertical already. No? Alright, so a while ago I did show you some kind of graphs, but these are the representation and visual graphs of hyperbolas. Alright, so we do have horizontal and vertical graphs. Alright, so what did you say? So it's horizontal because the A, this is just a tip, ha? The A of your equation is with the X. That's why it's in horizontal, because if you will see, we do have this x-intercept, or the axis of symmetry, no, is facing with the x, no. So therefore, our axis of symmetry is the x-axis, and you could see that your focus and vertices are with the axis of symmetry. Or in other words, if we are just pertaining with the axis of symmetry, most likely in ellipse, no, and ellipse and parabolas, no. But in hyperbolas, we have these two axes that we are telling, which are the transverse axis and the conjugate axis. So this is where the conjugate axis are going to be presented already to you, no. So what are the conjugate axis and transverse axis? So in a graph, no, this way. Alright, so in a graph, isn't it that I mentioned that we do have this kind of graphs? I'm sorry, erase this one. Alright, so we do have this kind of graph just like this, correct? And this is our vertex or vertices. We have the focus of, or foci, correct? And we do have the asymptotes, correct? Alright, so as I mentioned a while ago, the big tip that I will be giving to you is for the axis of symmetry. So if you say axis of symmetry, this is composed of two axes. What are those? Major and minor axes, correct? So that is applicable in uh, ellipse, but in this hyperbola we are using transverse axis and conjugate axis, where transverse axis is the axis that you could found within the vertex or vertices, correct? In ellipse, we could found that the vertices will be found at the major axis, which is the longer axis, correct? But in hyperbola, you could see a conjugate axis, no, with the co-vertices. So this is the other way around of the hyperbola and ellipse. So when we have, it seems like this is your major, this is your major, this is your minor. Okay, so it seems like just like that. But the correct terminologies that we have is the transfer axis and the conjugate axis. Okay, so in transverse axis, once again, we could found that one in your vertices, no? And the value coming from your center towards to your vertex is 8. Alright, and from your focus, okay, so from your focus, from your center up until to your focus, the value of that is C. Alright, so in total, if we're going to write it down already, so they are both equidistant, just like an ellipse. So coming from the centers, the two vertices are equidistant to each other, no? And the focus, to two foci are equidistant coming from the center. Alright, so when we have the vertices already, the value of this one is 2a. Alright, so they are just, we could see that it seems like the same with the uh, ellipse, but there are differences as well. Alright, so once we have the values for the, what else one, for DC already, in order for us to find the value of C is that we have to C in both ends. Okay, 2C. Because when you have C coming from your center, C coming from your center, so your focus is the value of C. When you have 2 at both sides, you could have 2C. Alright? So those are the things that you need to remember. Alright, so I guess so you are really prepared. So Sir Jai, how are we going to plot? Is it just the same of how do we plot in ellipse, or how do we plot in parabola? Okay, so in parabola we are plotting vertices, focus, directrix, latus rectum, correct? And we are finding the value of C. So in ellipse we are finding the vertices, focus, co-vertices, the values of A, B, correct, and C. Alright, so in this case, we are going to find the center first. Once again, center. So how are we going to find the center? From your formula, if you have H and K, so the formula and the standard equation that you could have is simply H and for the K. Correct? Alright, so how about for your vertices, Sir Jai? For your vertices, same goes by, huh? When you see your A is with the X, the one that I'm saying, what's the axis of symmetry? If it's in X, so therefore you are going to plot your vertices at the X-intercept already. For example, it is in origin, this is the one where you're going to add A. Alright? Same goes by for the focus or for the foci. Oh, why did we say so? We're going to add and subtract, take note, because your vertices are your vertex are 2. Now, if you say vertices, there are 2 vertex. And same goes by for your foci. So you're going to add and subtract at the x-intercept. Why did you say so that it is x-intercept? Because we remember that in ellipse, focus and vertices lies at the major axis. So they share one axis only. Alright, so therefore we could say that in focus, when you have uh, horizontal hyperbola, you could simply say that you're going to add and subtract the value of C in your x-intercept. Okay? Alright, so how about for surgery? How about for the value of C? There you have it, no? So how about for the value of C, surgery? So if we are going to say the value of C, you're just going to get that one, no? You're going to get that one coming from your focus. What's the value of the focus? I will be asking you, this is the focus, correct? This is the value of C, correct? But later on, you're going to know what if your focus not yet defined. Okay, so how about for your asymptotes, surgeon? Asymptotes, asymptotes. How are you going to identify what's your asymptotes, surgeon? For your asymptotes, you have asymptotes are your slopes. No, it performs a slope that defines that these are the lines that forms the boundary for your graph. Okay, and if we say slope, Again, say slope, that is rise over run. Okay? Mm. Take note, in your hyperbola, you have two asymptotes. Okay? You have two asymptotes. So therefore, you're not just going to get rise over run. So it will be positive and negative rise over run. And what are those rise over run? Because if you will say, coming from your center and up until to your vertex, it is the value of A. So therefore, the value of B is your co-vertices. Okay? So therefore, we could say that your asymptotes in this kind of graph, when you have the standard equation of x squared over a squared minus y squared over b squared is equal to 1. That is for this graph. So if this is your standard equation already, okay, so you could have your asymptotes with b, okay, b over a, which it would be multiplied by x, and you have the positive and negative, and that would be your asymptotes. Okay, once again, why did we say so? It's y. From the linear equation, y is equal to mx, and your m is v. What's your m? That is your slope. Oh, that is how you rise for your b. I will be highlighting her. You rise for your b, okay, and you run for your a. Correct? And if you will see, if you will notice, as we go to the right, the value of your slope is increasing. Correct? While in this other side, so therefore this is positive slope, positive slope. M is your slope, correct? So if we have for your left side, therefore it is your negative slope. So when you have this point, when you rise, how are you going to rise? Above or below? It is B, and your B is negative, correct? Your B is negative, so therefore you're going down, and you are going to the right because it's A, correct? Your vertical is B, and your horizontal is A, so therefore you're going to the right. And if you will notice, your slope are going down, correct? From right to left, or from left to right, no? So you will see the slope are going down. And with that, this is how the hyperbola. Alright? So let's try to have our hyperbola with an example. Alright? So first, before I give you an example, these are the things that we could see. Alright, so the values of a and b and c are related by the equation c squared is equal to a squared plus b squared. This is the one that I mentioned a while ago, correct? And also take note that the length of the transverse axis is 2a. And I mentioned this one a while ago as well. And for the conjugate is 2b. That is for the other vertices, correct? Or the co-vertices, correct? So I have this table. Alright, so when you have the center is at 0 or the origin, standard form for the equation of a hyperbola. Right, so you have transverse axis, no? When it's horizontal and vertical, correct? Alright, so if you will notice, a squared are with the x intercept because you have x with it, and once you have a squared for your y squared, your a connects with y intercept. Okay, so you are not just going to add, but you are going to subtract it as well because we say it is vertices, and if we say vertices, that is two pieces of vertex. Same goes by with the foci. Wherever did you put your vertices, that is the placement where you are going to add and subtract the value of sub c. Alright, so this is the one that I mentioned a while ago. So for your co-vertices, of course, that is the opposite, or the opposite placement for your vertices. So if you put in x-intercept, so your co-vertices will be inputted at y-intercept. Alright? This for the horizontal. And for your vertical, that is just the same. Okay? Alright, so how about for your asymptote, Sir Jai? This is the one that I mentioned a while ago. This for your horizontal. So why did it change, Sir Jai? Because if you will notice a while ago, your graph is facing left and right. So therefore, you're going to the right. Or you're going upwards. No? And if you will notice, it is what? It is facing like an. It is like. Yes, alright. So it is a butterfly. Correct? It is in butterfly form. So what are those butterfly? Oh, how about for vertical? If you say vertical, seems like it is an hourglass. Oh, what's an hourglass? Alright. So I will be giving you an a representation with the uh, terms for hyperbola. Alright. So these are the hyperbola terms. So we have the butterfly. So if we say so, it's butterfly. These are the terms that you could see when the center of your hyperbola is at H and K. Okay, take note ha, H and K. Okay, so H and K. So therefore, the center is not in the origin ha. So see, this is just the same with the origins. It's just that I make it as a butterfly. Now, if you will see, this is the wings. Correct? Alright. So, how is that surgery? So, what are the terms that we have? So, we have the equation form, okay, which is just similar for the ellipse, if you will notice, correct? So, the only difference is that this one. And for the principal axis or the transverse axis that you could say, correct? And for the center, they're just similar as well. Okay. H and K. Positive H, positive K. Correct? And for your vertices is at the points of red. And these are the curve or end curves, no, of your hyperbolas. Okay? Alright, sige. And we are going to add and subtract the values of A coming from this center. Oh, this is the one ha. I did mention last time, if you're going to have ellipse base, you're going to base on your center, correct? And after you have this one, base on the vertex, correct? So this is just the same. Okay? So for your co-vertices, you're just going to depend as well at your center. So if you add and subtract at the x-intercept, you're going to add and subtract the value of your co-vertices at your y-center. So how about for your transverse axis? What is that one, Sir Chai? Your transverse axis is your A. Alright, so that is your A. But take note, transverse axis, that is the value of the two vertex, which is 2A already. Correct? Alright, so this is your transverse axis. Alright, that is the transverse axis, which it performs like it's an axis of symmetry for your parabola. Right? Okay, sige. So about this one, if you will notice that the transverse axis is at the horizontal already. Right? So what's next, Sergey? So next is the value of transverse axis, and that is 2A. Alright, so also we have the conjugate axis, which has the center and for the co-vertices. Alright, so none other than it is centers and co-vertices. Correct? Alright. Okay. So if you will notice, they seems like similar really, no? And nothing is that kind of big. They don't have really big differences. If you will notice, they share the same values in ellipse. It's just that the two sides of your ellipse are just facing outwards. No? While ellipse is facing inside and it performs a closed shape. Correct? Alright, po, sige. So, for your conjugate axis, the length of that one is just 2b po. Okay? It's 2b. And for these yellow lines, these are your asymptotes. The value of your asymptotes is y minus k is equal to positive and negative b over a multiplied x minus hr. If you will notice a while ago, when the center of our hyperbola is at the origin, we don't have the values of h and k, correct? So it will just uh, stand alone as y is equal to positive and negative b over a times x. That's one, no? But if we have the values of h and k already, just perform the similar terms that we have in ellipse. X minus h, y minus k, correct? Alright, so our foci is this one. This is our foci. Alright, so we also have c squared is equal to a squared plus b squared in order for us to get the value of your foci. Okay, because the value of your foci is coming from the value of c. Okay, that is your two focuses each side po. Alright, so in that case, what I mentioned a while ago, wherever you put your vertices, whether in x-intercept or y-intercept, you just follow the vertices, no? From your foci, you're going to follow the vertices, okay? Alright, so same goes by for the hourglass. If we say hourglass, this is the timer, no? That composes of sand inside of that kind of cylindrical shape, okay? Oh no, cone, a cone or cone shape. Alright, so let's have the terms for the hourglass or the vertical uh, form for this hyperbola. So we have the standard equation, no? We also have the centers and the vertices, as well as the covertices and the transverse axis. Okay, that is our transverse axis, and you will see that is vertical. And as we mentioned, major axis and minor axis, they seems to be familiar. Sometimes they perform as equal as it is. Sometimes your x is equal, the value of your a is equal to your b. Sometimes b is greater than a, or sometimes a is greater than b. Alright, so sometimes it is just like this. No, a is greater or equal to b, or b is greater or equal to a. Alright, sige po. So let's have this one already. Okay, so the length of transverse axis, as we mentioned a while ago, it's 2a. And for horizontal, for conjugate axis, it's horizontal, of course, that is perpendicularly to our transverse axis. Same goes by for your major and minor axis. Alright, so they are perpendicular to each other, and as well as the conjugate length, which is 2b, of course, coming from your vertex, coming from the center to your covertices, coming from the center up until to the covertices, that is b. And if you are going to add two covertices coming from the center, that is the value of 2b, of course. And in order for us to find the value of foci, we have the value of c, no? And we are going to add c wherever we added and subtracted the values for vertices. So in this case, we have in y-intercept, so therefore we are going to add and subtract as well in our y-intercept. Okay? Alright, so lastly is our asymptote. So asymptotes in hourglass, if you will notice, the value of that is y minus k is equal to plus and minus, or add and subtract a over b multiplied by the value of x minus k. If you will notice, a is at numerator and b is at your denominator, because a is your vertices, correct? So a stands for the rise and b is your co-vertices, so you will be performing to the vertical. Alright, so you are going to write A, you are going to run B. Write A, run B. So this is your positive, and this is your negative. Going to write A, rise, positive A or negative? Negative. Run B, rise A, rise B, rise A, run B. Alright? That's how. Okay. So with that said, let's have an example already. No, so this will be quick. In solving a hyperbola. So we're going to find the vertices, co-vertices, asymptotes for this hyperbola, and we are going to graph it. So how are we going to find the co-vertices, vertices, and asymptotes? We mentioned that the standard equation is x squared over a squared minus y squared over b squared is equal to 1, or y squared over a squared minus x squared over b squared is equal to 1. So in this case, we have two type of standard equation, and if you will notice, this term or this equation is much similar to our example, correct? So what is the equation that we're going to use? The first equation that I've written now. So the first step in getting the vertices is to find the vertices, which is negative 7 and 0, and positive 7 and 0, and the co-vertices is 0, negative 3, and positive 0 and positive 3. So Sir Jay, how did it happen? So first things first, we need to find what are the values of a squared, a and b, and our givens are a squared is 49, b squared is 9, correct? So the square root of 49, or for us to get the value of a, is 7. Alright, and for our y, or the b, the value of b is 9, and the square root of 9, of course, we know that it is 3. We said that we are finding 4 vertices, so therefore you have 2 vertex, so you are going to add and subtract both sides because they are equidistant to each other. So therefore, coming from your center, what is your center? What is your center? Your h and k. Do you see any values of h and k? No. So therefore, your center is at the origin. So if we say origin, it's 0, 0. So therefore, coming from your center, your vertices are 0 and 0, correct? And 0. But you're going to add and subtract to your center with an a. And what's the value of a? It is 7. Add and subtract 7 to your 0. Correct? 0, add by 7, and negative 7. So 0 plus 7, the answer is 7. And the other coordinate is, you're going to subtract 7 to your 0, and it will become negative 7 and 0. So this is the case. You could just simply input as positive and negative 7, then 0. No? So this is your vertices. Okay? Alright. So I will be erasing this one. Alright. So that is positive and negative 7, then 0 po. No? How about for the focus, or I'm sorry, for the co-vertices? In order for us to get the co-vertices coming from your B, that is your 3 already. So you are going to add and subtract where? To the opposite placement that you've had for vertices. If you place your vertices at your x-intercept, you will notice your b squared is at your y-intercept. So therefore, you are going to add and subtract the value of b. And what's that? That is 3. Correct? I will be erasing this one, so that you will know. You will see. Alright, so the value of your b is 3. So that's why we have 3. But you're going to add and subtract. Why? You're going to add and subtract because you have 2 co-vertices in your hyperbola. No? So, what's your x-intercept? Your x-intercept is 0 because it's coming from your center. Okay, in order for us to get the coordinates of your vertices and co-vertices, we're going to base on our uh, center. Alright, so that is why we got the step 1 already, correct? So how about for the step 2, Sir Jack? So the step 2 is to draw a box using the vertices and co-vertices that we have. So if you're going to draw a box, this is our center, correct? So we are going to have, what is the value of your A? The value of A is 7, and we're going to have value of B is 3. Alright, so we are going to erase this one first. Okay, so coming from your center, you have the value of A, which is 7, value of B, which is 3. No? So therefore, we are going, no? We are going to graph already how would our graph would looks like. Okay, how would it looks like? Alright, so coming from your vertices, let's try to have negative 7 and 0, positive 7 and 0, and we have negative 3, 0 and negative 3, and as well as 0 and 3. Okay, so how is this one, Sir Jai? So we are going to uh, make a box with that vertices and co-vertices. Okay, that is a broken line. Why are we using broken line? In order for us, this is a line in order for us to be guided wherever our line is located. All right, so are we done already? So with this box, we are going to have the step 3. What is the step 3? Step 3 is to draw the hyperbola by using the vertices and asymptotes. Okay, so what is our asymptotes? Our asymptotes is the midpoint of the co-vertices and vertices. These are our this is our asymptotes. Okay, sorry if it's not really straight. That is our asymptotes. Okay, all right. So that is um that is a broken line as well. All right. So please, I just make it straight so that it will not be it will be viewed already. So Jai, are we done already? So based on the question, you're going to base on your question, huh? So based on the question, what's the question? Question is, we're going to find the vertices, co-vertices, and the asymptotes of each parabola. Only that one. Okay, so in this case, our vertices is this one, so therefore our graph is facing this part and this part. Okay, so this part, this one. Alright, so that is our hyperbola. Alright, so there are no focuses because we are not asked to find the focuses. Okay, alright po. So next in line is, let's write the equation of the hyperbola. So we're going to write an equation of the hyperbola with the center at the origin. So if you expect that you don't have any h and k in here, correct? So we have the vertex of 4 and 0, and our focus is 10 and 0. And we know that vertex has the value of a, and focus has the value of 10. Or value of c, correct? Focus is a value of c. But take note, in hyperbola that there is two vertices, there is two vertex and two focuses. So therefore, you could say that the other location or the other coordinates of vertices vertex is negative 4 and 0, correct? Negative 4 and 0. And for your focus, the other coordinate is negative 10 and 0. Correct? Alright. So if you're going to find the equation, how are we going to find the equation? So first step is we know that 4 is coming from an a squared, correct? What's the standard formula of this one? You know that they are located at the x-intercept, so therefore your x is the first term from the fraction, correct? And this is the operation, and therefore you could say that a squared is with your x squared. So therefore you could say that this is your equation, correct? Alright, so we know that, I'm sorry, this is 1, this is 1. Alright, so we know that a, the value of a, which is for the vertex, is just a simple a. So in this case, we are going to square because from the standard equation, it is squared. So therefore, the square of 4 is none other than 16. So we could input 16 as your a, and focus. How about your focus? None yet. Of course, in the standard equation, you cannot have focus without the value of c, correct? But what is the what is the what else one? What is the value for your c? Coming from the formula of c squared, correct? C squared is equal to a squared plus b squared. So, in order for us to know what is the value of c squared, knowing that your c is 10. So, in c squared, the value of that one is 100, correct? C is 10, so therefore, your c squared is 100, is equal to, what's your a squared? That is 16. And what is the number, what is the number that you could add to 16 in order for you to get 100? And that is 84, correct? Alright, so therefore we could have the value of b already. Okay? Okay. So, in this case, we are able to write the standard equation of your hyperbola. Okay, good? Good po. So we were able to write, and we are done already in writing the equation for your hyperbola. Okay. Alright, so how about this one? We're going to graph and label some hyperbola already. So we are going to find the coordinates of vertices, co-vertices, and foci in here. Alright, so this is the standard equation. So from your center, what is your center in here? The center, you could see that x has a number beside to it, right? So if you will remember, the number that is with the number that is partnered or beside with the x is h as well, h always, and for your y it is the value of k, correct? All right, so with that said, we could say that our center is located at -5 and 2. Correct? So, you could say that coming from your x minus h, the value of your h is equal to -5. So, when we substitute that one, x minus -5, what is the value? Subtraction, it will become positive, so it will become x plus 5. So that's why we have x plus 5, huh? All right, so we have now center of -5 and -2, and we are going to plot that one. So how are we going to plot? So this is your -5, 1 2 3 4 5, -2, this is your -2. All right, so this is your center. Okay, so uh, we are going to determine what is your axis of symmetry, or what is the transverse axis, whether it is in butterfly shape or hourglass shape. So if you will notice, our a squared is with your x, x variable. So therefore we could say that it is facing horizontal, or it's in butterfly shape. correct? So it's in x term first, correct? Alright, so since we could see that a squared is equivalent to 4, we could say that the value of your a is 2, right? So a squared is 4, but we only need a, so we're going to get 2 because we get the square root of both sides, correct? So we could say that in both sides we could have 2 and 3, right? Okay, so once we have them already, what's the next step? Hmm. Since we have the vertices, what is our vertices? A. So we could have the value for A in your x-axis because this is the x, because this is the variable that we could see along with your A squared, correct? So therefore, we could add and subtract the value of your A based on your center. What's your center? It's negative 5 and negative 2. So therefore, you could add and subtract 2 points to your left and to your right from the center. Okay, so if you're going to add 2 points and minus 2 points, so from your x-axis, so 2 points, 1, 2, this is your vertices, and this is your vertices. Okay. Alright, so that is your vertices. How about for co-vertices, Sergey? So of course, if you add and subtract to the x-intercept for your vertices, you're going to add and subtract to the y-intercept, to the opposite intercept that you've add for your vertices, correct? So therefore, you're going to add and subtract 3 for your co-vertices. So it's 1, 2, 3, 1, 2, 3. These are your co-vertices. And what's the next step? We're going to make a square, but before that we could find the focus already, because these are the things that we need to find all in this time we are going to find the foci, the vertices and co-vertices. Only this one, no, not the asymptotes. So in this case, we are going to find the value of foci. And how are we going to find the focuses of our graph? Using the formula of c squared is equal to a squared plus b squared. So what are the values of your a squared? Mm, it is 4, correct? So this one, it could be what else one, switch places, no, they're just the same, because whenever you add 2 plus 1, this is still equivalent to 3. It will be it could be 1 plus 2, it's still 3, no, but when it's subtraction, you cannot switch place two things. Okay, so the a squared, or we could just simply write it down already, c squared is equal to 4 plus 9, no? Therefore, your c squared is equal to 13. And with that, we could say that your c squared is equal to 13. Therefore, the value of your c is square root of 13. Or we could just simply say that we are going to add and subtract square root of 13. To where? Oh, from where? Alright, so focus points are the square root of 13 already. So coming from the center, coming from the center, what's your center? Negative 5 and negative 2. You're going to add and subtract, same placement wherever your vertex are. They share the same axis, correct? So you're going to add and subtract as well at the x-intercept. Okay? Alright, so with that said, that is just the same. You just get the value of square root of 13, correct? And you just locate that one somewhere in your graph. Alright? Okay po. And you could have your graph already. Alright? Okay. So, this is correct already. Alright, so we are going to graph, no? We're going to plot the center. Okay. And for much clearer plottings, no, this is our center, okay, and we have the value of a, which is 2. We're going to go left and right. For b, we're going up and down, correct? Because it's for co-vertices. They are perpendicular, and we're going to perform the shape one, no, or the square one, and we are going to place the asymptotes if you would like to, because they are the boundaries. Now, in order for us to know whether how wide or what is the form of your graph, no. All right. So therefore, we could tell that these are your graphs, correct? All right. So next, okay. So we do have this one. We are going to find the vertices, co-vertices, and foci. So same goes by. So in this case, we are seeing that y term is at the first term. Okay, the y is at the first term. So let's try to find the center first. Our center is -1. This is x minus h, correct? And this is y minus k. So h and k. So h is -1 and your k is +3, correct? So coming from your center, you could see that it is in hourglass shape. Why? Why? Because if you will notice, our vertices is at y-intercept. So therefore, your vertices is coming from this one. So obviously, you could sense that your graph is facing upwards and downwards, right? Okay. So, if you will notice, as I said a while ago, y terms are coming first term. All right, and we could say that a squared is our 4 and b squared is our 16. And if you're going to get the values of a and b, of course, it is 2 and 4. A for 2 and b for 4. Okay? Alright, so with that, we are going to get the values of vertices already. So how are we going to find the value of vertices? No? So vertices are 2 points, correct? So therefore, we could say that we are going to add and subtract as well. We're going to add and subtract. Going to the right side and left side? Is that so? No, of course. We are going to add 2 points upwards and downwards from your center. And what is your center? -1 and +3. Okay, so we're going to go 2 points, no, upwards and downwards coming from the center. All right, so co-vertices. How about for co-vertices? Because we are done already. We have the points for this, or coordinates for your vertices already. So how about for co-vertices? We said that co-vertices are the opposite vertices that we have, no, in our graphs or in our conic section. And if we say opposite, so if you added and subtracted in your y-intercept, therefore you're going to add and subtract at your x-intercept. And what's the value of your co-vertices? That is 4, correct? D is equal to 4. All right, so with that, we are done with vertices, co-vertices, and we are going to find the focus already. So how are we going to find the focus? Of course, using the formula of c squared is equal to a squared plus b squared, right? So with that c squared is equal to a squared plus b squared, we are going to substitute the values of a, no, in b. And with that, we could have the value of 20 for your c squared already. Okay, so we could say that c squared is equal to 20, or we could say that it is positive negative 2 times square root of 5. How did we say so? Sir Jai, can't we just simply input it as 20? Could be as well, positive and negative square root of 20. We just input this one in this case and this term because we factored it out. So how did we say so that we factored it out? What is the factor of your 20? It's the 4 times 5, correct? Inside the radical. So can you see any numbers between these two numbers, this 2 digit? Can you see any numbers that is perfect square? Is 4 perfect square? Yes. So what is the square of 4? It is 2. And how about 5? None. So therefore, you could have positive and negative 2. Then you just stay the 5 inside. So it's positive negative 2 times square root of 5. That's how. Okay? Alright. So we could now have the value of C. And we are going to add and subtract the value of C, or your focus, at your center. And what is your center? It's -1 and 3. That's how are we going to graph already? Now we are going to plot the center, and where is your center? It's -1 and +3, and we are going to go up and down. How many points? We are going to have 2 points up and down, up and down. Correct? So we're going to add and subtract. Alright. So after that one, this is our point. And with that one, the next is we're going to move 4 points going to the left and going to the right. Okay? Why? Because those are our co-vertices. Take note. And with that, we could perform a square like in that two vertices and two vertex and two co-vertex, no? All right, so we could perform, no, an asymptotes, and with that we could graph them already, right? Sige po. How about this one? All right, so we're going to find the vertices, co-vertices, and asymptotes. Take note, asymptotes of each hyperbola, and we're going to graph it. So step one. Step 1 is we're going to find the equation. What is the equation for this one? Of course, it is similar for the equation of x squared over a squared minus y squared over b squared is equal to 1. Correct? Because x comes first, no, in your first term. Right? And with that, we could simply say that this is the first term. And coming from your center, what is your center? Did you see any values of h and k? None. So therefore, your center is at the origin. Right? So step 2, how are we going to deal with this one? Step 2. Step 2 is that we could see that a squared, and this is the value of a squared, a squared, then b squared. So this is your a squared, then b squared. So your a squared is 16, and the value and the square root of 16. In order for us to get the value of a, it is 4. And with that, we are going to go 2 points, or we are going to add and subtract, no, coming from your origin 4, right? So we have the coordinates already for your vertices, and as well as for your co-vertices, because it is b, right? And with that, we were able to find the vertices and co-vertices already. Let's check this out, vertices and co-vertices, and we are going to find the asymptotes of each hyperbola, and we're just going to graph. That's all. Okay, so how are we going to find the asymptotes? What is the equation, or what is the uh, equation if we are going to have this butterfly? Isn't it this is in butterfly form? Because the axis of symmetry, or the term that you have, is x. No, if that's the case, no, so we could say that your vertices is at x-axis, or if this is your coordinate, your Cartesian plane, your x lies at x-axis, and you have butterfly already, correct? And you have your co-vertices, right? So therefore, if you are going to have your uh, asymptotes, what is the asymptotes? Asymptotes are your slope. And what is slope? Slope is m. And what's m? It is rise over run. So therefore, we could rise and run. And what is this one? This is co-vertices. And what is the value of co-vertices? That is b. So therefore, we could have rise for b, and we have run for a. So rise over run. Alright, so therefore we could say that our equation is y is equal to b over a, positive and negative b over a, no, times x, right? So therefore we could have our asymptotes already, correct? So we are going to graph it already. So how are we going to graph it? No, so coming from our center, this is our center, and this is our points. Positive 4, then 0, this is the one. -4 to 0, and 0, then positive 6, and 0, -6. So with that, we are going to perform a broken line. This should be broken line, this square shape or rectangular shape. This should be in broken line, as well as the asymptotes. Take note, ha. And where is our asymptotes? This is our asymptotes. Okay, this should be in broken line. Alright, so that should be in broken line. Alright, so we could say that our graph is, I'm sorry, there you go. Alright, it should not touch. Okay, it should not touch the, what do you call this one? It should not touch the asymptote. So this is our graph. Okay, next in line. So we do have, I'm sorry, next in line. Okay, so next in line is that we're going to write the equation in standard form. Take note, as standard form for each hyperbola. So what is standard form? It is equivalent to 1, of course. So we have the vertex and co-vertices. Alright, so we could say that our vertex is at the has the value of 9, right? So in this case, we could say that the other vertex is -9, right? So 0 and -9. So therefore, your vertex is placed at y-intercept, right? So maybe your vertex is located at y-axis, right? So therefore, this is your co-vertices, which is x-axis, x-intercept. So therefore, your A is at y. So therefore, your y comes first term before the x term, right? So therefore, this is your standard equation. Alright, so with that said, the vertex is on vertical axis, right? So your transverse axis, take note that transverse axis is vertical because this is your standard equation. But how are you going to find the standard equation for that one? Of course, we said that the vertex is the value of a, and we are finding the value of a squared. So if we have a is equal to 9, so we're just going to square 9. So what's the square of 9? It is 81, right? So therefore, same goes by for your vertex. And what's the square of vertex? The vertex is a co-vertex, no? The co-vertex, co-vertex, the value of that one is b, and if you're going to get the square of that one, no, the value of that one is 7 square, and if you're going to get the square of that one, it is 49, right? So therefore, we have the value of a and b. We could just simply write in this format, okay? And with that, get the square of each values, and you have the standard equation, right? Sige po, ha. All right. So for the, I think this is the second to the last, right? We are going to write the equation in standard form for each hyperbola. So we have these vertex and focus. So writing in standard form, right? So we have 8 and 0, then focus is 10 and 0, no? So same goes by, we could see that the vertex is at the x-intercept, and as well as for the focus. So therefore, we could say that it's in horizontal y, because we could see that vertex and focus are lying at the x-intercept. So therefore, it is formed as a squared, x squared is equal to x squared over a squared minus y squared over b squared. Alright, right, correct. Alright, so with that said, we could have the transverse axis for horizontal, no, and our standard form or equation, no, is this one. This is the one that I mentioned a while ago. And no, our step 2 in here is that from the values that we have, which is 8 and 10, this is our A and this is our C, correct, for focus. We could say that the values of A is 8 and the values of c is 10. Therefore, we're just going to use this formula, which is c squared is equal to a squared plus b squared, to solve the values of b squared, right? So with that, we're just going to substitute all the values of c and a in order for us to get the value of b squared. And with that, we could have 10 squared is equal to 8 squared plus b squared. Alright, so we are just going to substitute all, and we're just going to have the value of b squared already. No? Why did we have that one? Why did we have? Because what is your 10 squared? Your 10 squared is 100, and your 8 squared is 8 times 8 is 64, right? And you're going to add b squared, and with that you are just going to find the value of b squared. So you're just going to transpose your 64 to the other side. So 100 minus 64 is no is 36 already, right? So 100 minus 64, it's 36. That's why we have 36 is equal to b squared. Alright, so with that, we could say that our standard equation is x squared minus y squared, or x squared over 64 minus y squared over 36 is equal to 1. And with that said, I do hope that for this lesson, you've learned a lot, no, a lot of information with regards to hyperbola, and I do hope that for all the conic sections that we discussed, all of that will be inserted into your mind and your thoughts, no, because they are really interrelated and connected to each other, no. And with that, thank you for watching this video, and I do hope for your best test that we are going to have, no. With that, thank you and God bless.